All right, what'd you say, 12? Yes, Miss McGee, I said 12. Okay, then I must be on the wrong page. What are 2 different pages? Number 12. So I have this table, yes. A racehorse is running a 10 furlong race. As the horse passes each furlong marker F, a steward records the elapsed time since the beginning of the race shown in the table. I'm gonna just do all parts because I think it'll be easier. How long does it take the horse to finish the race? Well, that's easy. Do I need to copy the table for y'all? You see it? So how long did it take him to finish the race from start to finish? 135 seconds, right? Because that's what it... I'm gonna do this because I'm lazy. Y'all are not with me much this morning. Speed of the horse over the first 5 furlongs. What'd you do? From here to here, here to here, please. It's just a rock, right? It should be, it's y2 minus y1 over x2 minus x1. Right? So if, all right, wait. It's furlongs per second, right? Oh, yeah. So it would be 5 minus 0 over 80 over 73 minus 0. No, because F is furlongs and T is seconds. T is time. Generally time, because think about time is always on our x-axis, right? That's your independent value variable, right? So that's why we have to flip it. Really, this is like y and x instead of x and y. Well, if you want speed, I want the time constraint to be on the bottom, right? So if I do furlongs per second, so that would be F2 minus F1 over T2 minus T. So 5 minus 0 over 73. I don't know what that comes out to be, but furlongs per second. Does that make sense? Part C says, what's the approximate speed of the horse as it passes the 3 furlong marker? So here's what I got to think about. As it passes the 3 furlong marker, so I'm here. So this is where I'm going to use A rock to estimate I rock, right? So I'm going to take the 2 points closest to 3 on either side. So I'm going to go from here to here. And I'm going to do A rock between these 2 only. And it's going to estimate the middle. Does that make sense? So again, I'm going 4 minus 2, which is 2, divided by 59 minus 33, right? Or what you get. 1 over 13, which is approximately, yeah, 0.0769 furlongs per second. Or whatever. Does that make sense? During which portion of the race is the horse running the fastest? Between the 9th. Since these are all even, right? I mean, not even, but these are all equidistant. 0 to 1, 1 to 2, 2 to 3, 4 to 5, 5 to 6. Those are all 1. Right. Right. These are all just going 1 furlong each time. So if I look at these being equidistance apart, right? then which one does it get there the fastest in just one furlong? Well, this is 20 seconds. This is 13 seconds. This is 13 seconds. You see what I'm saying? So which one has the least amount of time between them to make one furlong? And that would be the 9th and 10th, right? That would be here to here. These are really just making sure you understand how to read a table is more than anything else. During which portion of the race is the horse accelerating the fastest? So this is a little bit different. Why? Because what? The biggest jump is what you're saying. The biggest, yes. Yes. Does that make sense? Part C. Okay, so the approximate, whenever I have a table and I'm asked to approximate IROC, I'm going to use AROC to do it. So if it's, because this is, speed is of course IROC, right? And it's wanting speed here for this one. So since I have a table, I go to the one left and to the one right, and I do AROC between those 2 points. What else? Study? Same section? One more. It feels so awkward in here today. Y'all gonna have to. All right, this is straight derivative, right? 4 over cosine. So I can pull the 4 out, yes? Everybody agree? That's going to help me as I find the derivative, because the derivative, whenever I've got a coefficient in front, I can just put it in the front, right? Okay. Tell me, because I don't have 1 over cosine on my hot pink sheet, right? I have cosine. Okay, give me another way to write it. Secant, right? So this is secant x. Do you agree or disagree? Agree. Agree. Do you? Does it say what? No, so you want to write it on there. That's from your basic ones in pre-cal. So cosine, tangent is sine over cosine. Secant is 1 over cosine. Cosecant, oh, I swear, didn't we do this in, okay. Okay, that's okay, that's all right. Little different than inverse. We're doing the derivative. I haven't, all I've done is rewritten it because I didn't know, I didn't have 1 over cosine on my sheet. And I don't know how to do that. Now you could go through. You could go through and do quotient property here. Is that what y'all tried to do? Okay, well let's do it. Let's do it. I'll do it both ways so you can see. Because this is when I can't, somebody was asking me, it might have been you, Stella, could you derive them each time? Or maybe it was Madison. I can't remember. Somebody up here was asking. If you didn't remember all of these, could you derive them on the exam? And the answer is yes, most of them you can. So here, if I did the derivative just from this point, I do derivative of the top, which is 0, times the bottom, minus the top, times derivative of the bottom. What's the derivative of cosine? Negative sine x over the bottom squared, which will be 4 sine x over cosine squared x. You'll want to write it like this, because if you write it this way, it looks like the x is squared unless you do it like that. You can do it like that, and that's okay. Okay, that's fine. Yeah. Now, If you use the secant, right, if I come over here and I said 4 and I look on my hot pink sheet, I don't even remember if we talked about secant. We didn't really talk about it on my sheet. The derivative of secant is what? Look on your sheet. Secant x tangent x. Is that the same thing as what I have over here? Yeah, that's exactly right. I could pull the 4 out. I could do sine over cosine times 1 over cosine, because I have 2 of them, right? Sine over cosine is tan. There's your tan. 1 over cosine is secant. There's your secant. Well, so unlike an FRQ or an open-ended test, no, you could, either one of those would be acceptable. You could go here or you could go here. But if you're on a multiple choice, you have to be able to recognize being able to work with them. A lot of these trigs, you're going to have to work with them and manipulate them, something like this, to get where you need to get. We'll keep practicing with that. Y'all are not happy today. What the world? Oh. Number 1. Well, you have to, because remember those properties of derivatives. So I can do the derivative of each individual part. Well, the derivative of 1 is 0. Derivative of x is your right is 1. What's the derivative of sine x? Cosine x. So it's just minus cosine x. Oh, sorry. So that would be plus sine x. Yes. Ooh. I like number 9. I think we should do quotient on number 9. What do y'all think? What you did? Just take it step by step. And you've got your pink sheet, so this should just be plug and chug as you go, right? Right. Derivative of the top. What's the derivative of cotangent x? Negative cosecant. We're not killing kittens today. That's the derivative of the top, yes? Say yes, because that's right. That's right off your pink sheet. Times the bottom minus the top, which is cotangent, times derivative of the bottom. 1 plus cotangent, what's the derivative? Negative. Are y'all with me? All over the bottom squared. Now here's where I'm going to have to work with it just a bit. Be Robert's favorite. The bottom's already in fully factored form. I can leave that. But up top, some things are going to happen. As I come here and I distribute minus cosecant squared x cotangent x. And I'm going to show you what we're going to do with it in just a second. This is going to be plus. Oh, I might not even have to do anything. Oh, y'all got lucky. I was ready to manipulate the snot out of this thing. No! I was fixing to change all my cofunctions to basic trig functions, which is a good tool to have to be able to do as you try to simplify and move around. I was fixing to change all the cotangents to cosine over sine, all the cosecants to 1 over sine, and see what canceled out that way. But, lucky for y'all, you little lucky ducks, that just cancels as it sits. So then, yeah, you're done. I would stop there. Is that not where they stop? I don't know if, yeah. No, they went through some properties, some trig. I'm okay with you stopping there. You could go through if you change these now too. The top would be 1 over something. You don't care. Okay, I'll stop. What else for your homework? Number 6. I think these are fun. When you have your pink sheet. When you don't have your pink sheet, you start to sweat bullets a little bit. All right, derivative here. What's the derivative of 3x? 3. Product. Derivative of the first times the second plus the first plus derivative of tan x. That one comes up a lot. You'll remember it whether you want to or not. What? Because it's x times tangent x, isn't it? Y'all are making me feel like I'm losing my mind. I forgot what the first. Derivative of first times the second plus the first times derivative of the second. I'd probably stop there. $10 million. Here. So I did derivative of the first times the second plus the first times derivative of the second. Because it's multiplied, because that variable. If that had just been a coefficient, I could have pulled it out and not worried about it, but because it's a variable, it's a whole function there, so I had to. Yeah, let's take just a second in between. What y'all have for homework through 10? I'm telling you. It is hot. Show what? Yeah. Show that these two have horizontal tangents at x equals 0. Same thing we did Friday. This is just another day on it. Are we learning? Are we learning new stuff? Yeah, but how am I gonna work problems like that? Drag this down the stairs. It's broke. Well, if anybody has like a class that somebody needs to have access to the elevator, we have to move the class for it until they come. How am I going to show that they have horizontal tangents? What the heck? I know it. I know it. Hold on. Tell me, okay, I'm ready now. Sorry. I was designing on which problems I was going to work with you on which one. Is what? Set the derivative. Well, For this one, since it's telling you, I think they have a horizontal tangent at x equals 0, how do I show that? So I'm going to find the derivative first. What's the derivative of secant x? Secant x, tangent x, right? Now, if I didn't remember that, I could change it to 1 over cosine. Everybody remembers cosine, sine, and tangent, or you will. And then you could derive it due to the quotient property from there. But this says show that they have a horizontal tangent at x equals 0. So what should happen if I plug 0 in for x? I should get 0, right? So what is secant of 0 times the tangent of 0? I only need one of them to be 0 for this to work. 1 over cosine 0 times tangent. So what's the cosine of 0? Think about your unit circle. At 0, it's 1, right? So do I have a horizontal tangent at 0? That's right. Yes. So the slope of the tan line at x equals 0 is 0, which means it's a horizontal line, right? Y'all seeing how this is coming? I'm just doing that for you so you know. The slope of the tan line when x equals 0. That's what now if they asked you why, yeah, you'd have to say yes, it has a horizontal tangent at x equals 0 because the slope of the tan line at 0 is 0. Right? Because that's what horizontal tangent means. Anytime you see horizontal tangent, I'm thinking slope of the tan line is 0. But it said for both of these. So cosine, what's the derivative of cosine? Negative sine. So if I put 0, because this time it gives me 0, right? So if I put 0 in, what's the sine of 0? So the slope of the tan line when x equals 0 here is also 0, which tells me, yes, there is a horizontal tangent. Does that make sense? What? Well, it was just two different problems. It said, show that the graphs of this and this both have horizontal tangents. So, all right? Well, you would just need to show this. I would probably say, where does it have a horizontal tangent? Somewhere. But it's a little tricky with trig functions because you'd need a domain restriction. I'd have to say between here, because you know they're repetitive. So they keep hitting 0 over and over and over, unless I gave you a range to look at. Does that make sense? Okay. Try this one. I'm trying to do one of each type of problem you're going to have in your homework tonight. Yeah. Find the points on the curve. And this, here's that domain restriction I was talking about. Before I even do anything else here, what does that mean? What quadrants am I talking about? 1 and 4. I'm here and here because this would be negative pi over 2. This would be positive. Remember, negative goes opposite direction, right? So I'm talking about the two right quadrants here. Okay? But anytime you do a negative, if you're looking at a negative radian, that means you start here and you go clockwise instead of counterclockwise. So this is negative theta. This is positive theta. Now, if I went, so your unit circle pi, this is 3 pi over 2. This is 2 pi. But I can always go backwards on it, right? I could say, okay, where are you? Where are you? You tell me, where are you at negative 3 pi over 2? At pi over 2. Because if I go backwards that many clicks, I end up right here. All right. Find the points on the curve where the tangent is parallel So this time I'm not telling you where at x equals blah. I'm saying where the tan line is parallel. So Lainey, you're right. That means that my slope, again, my slope has got to be 2 because that's what it means to be parallel, right? Same slope. Yeah. So that was given. Everything in black up here is given. So, well, but not the circle. If I know my slope is 2, what do I need to do? What describes slope? Derivatives. So let's find the derivative. What's the derivative of tan x? Yes? What do I need this to equal? 2. Where is secant squared x? 2. Well, how do I solve that for x? Okay, let's do this first. Let's get rid of the squared. Everybody okay there? Secant x is the same thing as 1 over cosine, right? If I flip both sides, can I do that? Can I just reciprocate both sides? Can I say 1 over square root of 2 equals cosine x? Where does, you can, so, and that's what you're used to seeing on your unit circle, right? If I get the radical out of the bottom, I got square root of 2 over 2. Positive or negative equals cosine x. So when you take a square root, it's positive or negative. Because in the very beginning up here, when I took that square root, what? What's square root 4? So what's negative 2 times negative 2? Square root of 2 over 2 or negative square root of 2. Cosine is the what value? X or y? The first one, okay? This is why it's important to know which quadrants I'm working in. Remember I told you I was just on this right side? Where on just that right side does the cosine value equal square root of 2 over 2 or negative square root of 2 over 2? Pi over 4, negative pi over 4, or, and we'll do it that way since it's in our domain. Yes. Irrational. Huh? What did I add? I rationalized the bottom. What's this stupid thing doing? Okay. Are y'all with me now? So the question is, at this point, where, remember, I've got to stay in that same defined domain. It's telling me I've got to be between negative pi over 2 and pi over 2, right? So I come on my unit circle and I say, where's cosine, which is the x value? So whenever I'm in this side of the unit circle, where is cosine? Again, the x value. Where is the x value? Either positive square root of 2 over 2 or negative square root of 2 over 2. Pi over 4. And I'm not going to call this 7 pi over 4 because that's not in my domain, but negative pi over 4 is. So really it's plus or minus pi over 4. Because if, right, because my domain includes negative values, so instead of looking at this as these values, I'm going to look at it as negative pi over 6, negative pi over 4, negative pi over 3, and negative pi over 2. Those are those coterminal angles like we talked about in pre-calc. And here, yes. But because I'm in this, it's also here. Because see, this is pi over root 2 over 2 also. Pi over 4. Or negative pi over 4. Trig gets y'all every time. It really don't. Okay, so at least do at least one of those easy ones like root 2 over 2 where they're the same. The over 4s are easy for you, or should be easy for you. Oh, let's carry on. What number was that? All right, so the one that you'll have to do on your own is square root of 2 times cosine x, and you'll do the derivative. It's not quite as hard. I did the little bit harder one with you. But okay, let's do another one. What's your homework for tonight? We haven't quite got into review yet. Still in this deep dive into trig derivatives. This is 31. All right, that's a horizontal tangent. Obviously, these are supposed to be tan lines here at these points. This is 1. This is the graph of y equals 4 plus cotangent x minus 2 cosecant x. Two things here. I want an equation of the tan line at P, and I want the horizontal tan line at Q. Marks that guy. Mm. Good. Let's do tan line at P first, because P gives me a point. All I need is a slope, right? Because all I need to write the equation of a line is a point and a slope. So I have the slope. So let's go through and let's find. How do we find slope? Derivative. So let's first find the derivative of this monstrosity. Derivative of cotangent, because the derivative of 4 is just 0, right? What's the derivative of cotangent? Negative. See, I don't remember that one. I have to derive it. Did you get that from the pink sheet? Minus 2. What's the derivative of cosecant? Negative cosecant x. Everybody okay? All right. So literally all I have to do, I'll do plus 2 cosecant x cotangent. I need to plug in this x value so I can find the slope there, right? Did you? Good. Negative cosecant squared, I'm at pi over 2. Plus, and pi over 2 is a great value to be at. Why? It's right at the top of my unit circle. What are the coordinates at pi over? This is pi over 2. What are the coordinates at pi over 2? 0, 1. Cosine is 0, sine is 1. Great place to be to have to find all these nasty trig values. All right, so 2 cosecant pi over 2, cotangent pi over 2. What do you mean you kept going? Okay, so if I'm asked to find a derivative, right, and I'm not asked to find it at a specific value, I may need to keep going. But if I'm asked to find the slope, which is what I'm asked, right, the value at a point, well, I'm going to plug in as early as I can because I might be able to solve it without doing any more manipulation. It is hot. I'm about to die. No, that's not the answer. I need a value. All right, so cosecant, right, cosecant is 1 over sine. Agreed or disagreed? Okay. What is the sine of pi over 2? 1. So this is 1 over 1 squared. Do you agree? Is that too much? Skipping too much? Okay. All right, let me write out a little more. I'm going to write this as negative 1 over sine squared pi over 2. I'm going to break these down into basic trig functions so you can see where everything's coming from. Plus 2 over sine pi over 2, tangent pi over 2. Now here's the only thing I'll caution you about as you switch these around. This would give me 0, but this gives me undefined. Why? 0's on the bottom right. So here, really what I need to evaluate it at this step instead of this step, because if I'm multiplying by 0, that's just knocking that whole thing out. It doesn't matter what anything else is. So delete that, right? Gone. Do you see why though? The cotangent of pi over 2 is 0, but 1 over tangent is still undefined because tangent's undefined. So I have to think about it like this instead of like this. So I need to kind of think about it this way. That's the only one that starts getting, so that whole second half, right? Because 0 times anything, I don't even care what this is, because if I've got 0 in there, it's just going to be 0, so I don't even care. So now the question is, what is the sine of pi over 2? Again, I'm up here at the top. I'm at this point right here. What's the sine of pi over 2? 1, and I'm squaring it. So what's the slope? -1. What was my original point? What was my p? Pi over 2. I've got a point, and I've got a slope. Write the equation of the line. Y minus 2, slope, x minus, and I could solve that for x, for y very easily. How tangent? Look at your cotangent. So remember, tangent is sine over cosine, right? And we said up at this point, this is the point 0, 1. If I do 1 over 0, what happens? I'm undefined. But if I do cotangent there, cotangent is cosine over sine, which is 0 over 1, which is, when you type what are you typing? Are you in radians or degrees? Hit mode. Be in radians. Pi over 2 is a radian measure. Probably should not have. Yeah. Y'all are dead. All right, let me give you your homework because y'all are just staring at me like I have a second headache. All right, 152 to 153, you're going to do 28, 29, and 32. Those are one each of the examples like what I did. 46 through 48 are your multiple choice, and then you have 1 through 4 on the AP quick quiz. Tomorrow we'll start review. Definitely try all parts of number 4 here on this quick quiz. I mean, try them all, but that's really important.